the third time I've tried to make this video. Mr. Kincaid was being a loud mouth outside my door, trying to think of nice words. Okay, so this is the preview for your lab that you're going to be doing on Monday. As you can see, you can pause it at any time, but I just highlighted a few of the keywords that you're going to be dealing with. Data, which must be measurable and have units. Accuracy is the degree of correctness, meaning nearness of a measured value to its true value. And precision is like how many times you can repeat it over and over and get the same result. So those are the things we're going to be looking at. We're not just going to be measuring this year, we're going to be learning how to be accurate and precise and what that means. So on the back, you have diagrams of what each one of those words means at the top to help you visualize it better, and then you have your 4 pre-lab questions. But what I want to go over with you really quickly are the parameters of what you're going to be doing in class. This does involve some math and calculating after you get it measured. So meters, again, are slightly larger than a yard. Liters are larger than a quart, and a milliliter is approximately 20 drops. And weight, 2 paper clips weigh approximately 1 gram. And I hate that it uses weight. Notice I wrote mass on my paper because weight can change depending on gravity, and the balances that we use do not deal with weight, they deal with mass. It talks about the metric system. You have notes about that. I have a video recorded. I haven't figured out how to get it to you yet, but you will see it eventually. And then it talks about micrometers or microliters or micrograms, which are 1 to the times 10 to the negative 10th. So they are smaller than milli by 3 factors. You're going to be doing linear measurements, so you'll get a ruler and just look at it real quick. Step 2 says you're going to estimate the size of each object listed in table 2.2, and then you'll write it down, make your estimates in metric, and then you'll use your metric ruler to measure them and record your measurements. And then step 4 is you're going to use this formula to calculate the percent error for your estimates, and that's looking at your accuracy of estimation, which is your estimated value minus your measured value divided by your measured value times 100. So you'll do that, but you can do the math after you get all of your measurements done. That way you can make sure you use your class time wisely to get everything done you need to complete. As you can see, this whole next page pretty much is pink. So for the weight measure or the mass measure, again, you're going to estimate, then you're going to find the mass, you're going to record both of those things, and then you're going to use the same formula as before. Now, I'll do another quick video to show you how to use a pipette. No, I won't. I'll just show you in class. But you'll be given a pipette and a pipette pump. If you had Mr. Johnson for chemistry or college bio, you've probably done something similar to this before. But you'll have one beaker set up as your source beaker, as step 9 refers to, and another beaker that's going to be your empty beaker. You're going to find the mass. It says weigh for number 10, but you'll find the mass of the empty beaker to the nearest 1/10 of a gram and write the weight or the mass down. And then you're going to pipette the amounts that it tells you to in number 12. You'll pipette those out one at a time into the empty beaker, and then you'll switch halfway through so your partner can also pipette it down, and you can mark them out as you go. And we'll go over how to pipette in class for step number 11. Then you'll find the mass again after you have the water in it, and you'll subtract and record the final mass. And then you'll calculate the experimental volume of water that you pipetted using this formula. And it tells you on the next page that the goal was supposed to have 40 milliliters of water. And hopefully you remember from your metric notes that 1 milliliter of water is equal to 1 gram of water. So if you did it right, when you subtract, you should have 40 grams of mass added to your beaker. And then once you figure all of that out, you will use this formula and figure out your volume that should have been the ideal, which is 40 milliliters, and then your theoretical ideal volume. oh sorry, that's your 40, and then your experimental is whatever you got. So how accurate were you? And then number 17 asks you for some possible sources of error. So where could you have messed up? Then you have questions 4 to 5 to answer on the data sheet. You'll make 2 graphs. That'll be done in your own time as part of your lab report. And it walks you through how to do that, those 7 rules. I did not provide graph paper, but I will give you some in class if you need it when you come to class on Monday or Thursday. And then it tells you to construct your line graph, and you'll use this data to do so. And then it's got a little bit of finding the rate, and hopefully by your junior year you found the slope of a line before. Y1 minus y2, I've always heard it y2 minus y1 over x2 minus x1, but either way it'll be the same, and you can calculate the rate that way. And you'll record the slope next to your lines. So you'll do that. And then the bar graph, I didn't highlight too much, but again, it's got rules that you want to look at, and it describes how this is for non-continuous or individual observation in categories, and line graphs, if you go back, it says it's for continuous data collection. So it walks you through how to do it. It gives you your table that you're going to do and tells you how you are going to set up your bar graph. And again, I'll give you paper for that if you would like. And then you have questions to answer on the data sheet. So here's your data sheet. The items that you're going to look at and measure are a glass slide, a plastic beaker, and a pipette pump. Those are the things you're going to estimate, measure, and do your % error. So pretty much what you're already going to be having in class. We're not going to get any more items out, and that's what you'll use. So hopefully you should be able to finish this within one day, and then the next day we can work on your microscope review of how to use a microscope lab. And the questions and the calculations you can do when you're working on your lab report at home. So I hope that's helpful.